Hey guys, this is Kerry, and this is the answer key video for homework, extra credit homework 3. So it's worth 2 homeworks. The Wells family is looking to purchase a home in a suburb of Rochester with a 30-year mortgage that has an average interest rate, or an annual interest rate of 3.6%. The house the family wants to purchase is $152,500, and they'll make a $15,250 down payment and borrow the remainder. Use the formula below to determine their monthly payment to the nearest dollar. So it actually turns out this is one of the easiest problems you would ever encounter on the Algebra 2 Regents, except the formula looks really horrible. So to plug in everything here, it turns out that the first thing you have to figure out is the amount that they borrow. That's going to go in P. So because the total house cost is $152,500, and they pay this down payment up front, then the amount they have to borrow is the original amount minus that, and that gives us, let's see on the calculator, 152,500 minus 15,250. That gives us 137,250. So that goes here. Next up, we have to do the rate divided by 12, so 3.6. But remember, when you use decimals in formulas, we have to use percents in formulas, you have to use the decimal version of those. To the nth power, so n is the total number of monthly payments. Because this is a 30-year mortgage, it looks like we'll have to do 30 times 12. 30 years times 12 months per year is going to give us 360 months, or 360 payments. So that'll be 360, and then this is all divided by 1 plus 0.036 divided by 12 to the 360 minus 1. So this is actually a really nice problem because once you've plugged everything in, there's no algebra to do. This is all just a crazy formula. So if you're careful with your parentheses, like we had to be on extra credit number 2, some type of problem, then we'll get the right answer. So let me do that on the calculator. So parentheses 137,250 times 0.036 divided by 12 times 1 plus 0.036 divided by 12 to the 360, close parentheses, divided by open parentheses, 1 plus 0.036 divided by 12 to the 360 minus 1, close parentheses. And it looks like I'm getting m is equal to $624 when I round. So hopefully that's right. If it's wrong, I know you guys will tell me. All right, so problem number 2 is based on extra credit number 1. So an angle theta is in standard position, and its terminal side passes through the point 2, -1. Oops, that's not 2, -1. 2, -1 would be all the way over here. So its terminal side passes through to -1. Now we want to determine the exact value of secant of theta. So secant of theta is one of the reciprocal trig functions, which means it's the flipped version of, if it's the S one, it would be cosine, because S and C always change when we flip it. So secant theta is going to equal, well, we probably want to use the coordinate plane versions of these formulas. So remembering the coordinate plane versions, sine of theta is y over r, cosine of theta is x over r, and tangent of theta is y over x. Secant of theta is going to be the flip of cosine, so that will be r over x. Now we've got x, we've got y. To find r, we use the Pythagorean theorem. And you guys can calculate it in detail, but I found using the Pythagorean theorem that you get square root of 5 here. So this is going to be square root of 5 over 2. So I'll write a note that that was from a squared plus b squared equals c squared. Next up, which of the graphs has the following characteristics? 3 real zeros. So zeros are where the graph hits the x-axis. So this one has 3 zeros, this one has 3 zeros, this one has 3 zeros, and this one has 3 zeros. So they all have 3 zeros. Now, to check the end behavior stuff here, as x approaches infinity, that means the right end behavior, because x is approaching positive infinity. So as x moves to the right, we want f of x to approach negative infinity. We know that f of x is another way of saying y. So as we move to the right, we want y to approach negative infinity. So this would be going down forever. So on the right side, this one is going down forever. That looks good. On the right side, this one's going up forever, so we can cross it out. On the right side, this one's going up forever, so we can cross it out. And on the right side, this one's going down forever, so we have to leave it. This one says, as x approaches negative infinity on the x-axis, that would be to the left. We want it to go up, y to approach infinity forever, so that's up. So on the left side, this one does go up, so this meets all of the conditions. And on the left side here, this goes down, so this violates this condition. For problem number 4 here, solve the following system of equations algebraically. This looks like one of those ones that we would be better suited to solve using substitution. So solving the second equation for x will give us, I'm going to divide both sides by 2. That gives us x plus y equals 5. X equals negative y plus 5. Substituting that in for x here gives us negative y plus 5 minus 3 squared plus y plus 2 squared equals 16. This is negative y plus 2 times itself, because we're squaring, plus y plus 2 times itself, because we're squaring, equals 16. Distributing here gives us y squared, minus 2y plus 4 plus y squared plus 2y plus 2y plus 4 equals 16. Negative 2y plus 2y cancels out, negative 2y plus 2y cancels out, and we get 2y squared plus 8 equals 16 when we combine like terms. Minus 8 on both sides, 2y squared equals 8. Divide by 2 on both sides, y squared equals 4. Square root both sides, and we get y is equal to 2. But square roots to cancel squares gives us a second solution, which is negative 2. Now, the last thing is we need to plug in to find the x values for these. So you can use either equation. So I will probably use this equation. So we get 2x plus 2 times, when y is 2, we get 2x plus 2 times 2 equals 10. X has to be 3, skipping some of the steps. And from this one, when we plug in y equals negative 2, you plug into the same equation, 2x plus 2 times negative 2 equals 10. And we find that x has to be 7. So the final answer to this problem is the point 3, 2 from the first one, and the point 7, negative 2 from the next one. Okay, great. Now finally, we've got one of these crazy systems of equations problems with 3 variables. You might need this for your delta math. This is the last question. So to solve this one, what we do is, well, this one's a little bit weird. We've never encountered this. It's got the a on this side. You want to turn it into a problem that's more familiar, so you subtract a on both sides of the third equation. And that will turn the third equation into, just to avoid rewriting it, negative a plus 6b plus 2c equals 14. Now, pairing things up here, we're in the perfect situation because we've got 2 with the same sign and our helper equation, which has a different sign. So we're going to pair up equation 1 and 3 and equation 2 and 3 separate. So let me do 1 and 3 first. Here's 1, here's 3. So we do a plus 4b plus 6c equals 23. And then we pair it up with 3 because 3 had the negative version and the matching coefficient. All right, so we add these 2 equations. That gives us 10b plus 8c equals 37. Now we take the other 2 equations that have opposite signs, which would be 2 and 3. So when we pair 2 and 3 up, we get a plus 2b plus c equals 2, negative a plus 6b plus 2c equals 14. We add those, these cancel out. That gives us 8b plus 3c equals 26. We put these 2 equations together now because now we just have a smaller system of equations. 10b plus 8c equals 37. 8b plus 3c equals 26. So unfortunately, we're not so lucky at this step because none of our rows match. So we need to make one of our rows match. So I actually think it's easier to make the B row match this time. So I'm going to multiply this equation by 8. That's going to give us 80b plus 64c equals, I'm going to use the calculator for this one. 8 times 37 is 296. Then for this one, I'm going to multiply this one by negative 10. Negative 10 times 8 gives us negative 80b minus 30c equals negative 260. And now we can actually just add these two, because now that this column is matching with opposite signs, they cancel out. So that gives us 34c here, and that gives us 36. Oh no, I must have made a mistake. Shoot. Let's see. 23, 14, 10b, 8c, 8b, 3c, 16 here. Okay, cool. So it's a small mistake. Hopefully you guys caught it before I caught it. So this is 16, which would mean this is minus 160. Sorry for the mistake there. Let's see, 296 minus 160 is 136. So one thing we've learned about these problems is they're a little deadly if you do make a mistake, because you'll get a decimal answer. But now that we fixed it, hopefully things work out. So we do the final division by 34, and it does work out. We get C is equal to 4. Next up, we need to find A and B still. So if we take this equation right here, and we plug in for C, we can solve for B. So that gives us 10b plus 32 is equal to 37. We minus 32 on both sides. That gives us 10b is equal to 5. And we are going to get a decimal here, even though I believe we did it correct. We did. So we divide by 10 on both sides. That gives us b equals 1/2. I guess it's a pretty friendly decimal. And then lastly, to find a, we'll use any of the starting equations. So for this one, we'll take the first one. So it's a plus 4 times 1/2 plus 6 times 4 equals 23. That gives us a plus 2 plus 24 equals 23. A plus 26 equals 23, and we find that a is negative 3. And so we've got our solutions. And if we don't believe them, we can plug them into the other ones. So negative 3 plus 2 times 1/2 plus 1 plus 4. That's going to work. It checks out here. And I'll leave the last one for you to check if you're interested. Hope this video was helpful, guys. See you in class tomorrow.